QSO Today, episode 198, Jack Mandelman, K1VT. This episode of QSO Today is sponsored by ICOM America, where May is D-Star Month. Check out ICOM's line of mobile and portable D-Star transceivers. And by QRP Labs, Hans Sommer's amazing electronic kit company, where you can get his new QCX transceiver kit for under $50. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth4Z1UG, your host. I don't often get to speak to an amateur radio operator who has over 700 patents worldwide, but my guest today, Dr. Jack Mandelman, K1VT, owes his commercial success to his early beginnings in amateur radio. Jack shares his story and his involvement in the semiconductor industry during the 60s when America was focused on getting men to the moon. While antennas and antenna projects were the center of his ham radio life, Jack is moving on to new technologies. I found him on DMR and invited him to this QSO today. K1VT, this is Eric, 4Z1UG. Are you there, Jack?
Yes, 4Z1UG. Here is K1VT. The name is Jack. We're doing fine. You sound good, Eric.
Well, thanks, Jack. Thanks for joining me on the QSO Today podcast. Can we start at the very beginning of your ham radio story? When and how did it start for you?
Well, as many kids of my age in the late 1950s, it started with shortwave listening. But before that, I had an interest in radio and electronics. My dad encouraged me. I remember a kit that he got me where I think it had one single vacuum tube, but it had these snap-on wires that would snap on to connection points, and you'd build up a circuit that way. And I built some simple circuits, including receivers, using that method. And that got me interested in just listening to the shortwave. Shortwave was such a big thing back then in the late 50s. My dad bought me an S38E, Hallicrafters S38E receiver, which used the so-called All-American 5 tube lineup. And if you're not familiar with the All-American 5, it had 5 vacuum tubes. It was an AC-DC receiver, meaning that you could use a DC supply from the wall also. So what they did was they wired the filaments in series in order to get the proper voltages for the tubes in the circuit. And I started listening, and I found out that there was a ham fairly close by who later became my Elmer. I didn't get the nerve to contact him. It took me about a year before I had the nerve to knock on his door and introduce myself.
So then, what happened? You decided to finally get the nerve and go up and knock on the door?
Yeah. It took a long time. It took about a year. But I said I knew other friends who were interested in ham radio, and I said, let me be the one to see what his shack is like.
So you knocked on the door. What was his reaction?
Oh, he was very friendly, and his call was W2IRS. He used the phonetics Irish Radio Shack. He had a very deep brogue, and he was a retired New York City police officer, and he was very welcoming to his shack. I went up to his shack, and I saw he had some World War II surplus equipment. One was an ART-13 transmitter, and the mercury vapor rectifier tubes fascinated me because as he would talk and draw current through the rectifiers, the glow of the rectifiers would change, and it was kind of mesmerizing. He also had a Hammerland Super Pro receiver, which was very popular in the day. It was a good receiver. And this was back on AM. I used to listen to him on 40 meters. I'd listen to him in the afternoons on 40. until the band got so congested with shortwave broadcasts, including Radio Moscow, that even though he was a local, it was very difficult to continue operating on the 40-meter phone band at that time.
Now, you said that you went to his door representing some of your friends. Did you and your friends actually get together into ham radio at the same time?
Well, what happened was after I got into ham radio, I met other kids who were into the hobby.
There weren't any non-hams that came along with you on the journey with W2IRS?
That's correct.
And where was the hometown?
This was in the borough of Queens in New York City. The specific area of Queens was known as Maspeth, M-A-S-P-E-T-H, named after native Indians who used to live there.
And how old were you then when you first got your first license, and did he help you get your novice?
Well, he actually didn't help me get my novice. He just inspired me to get it. I was 14 years old when I got my novice, and I remember the ham that I went to take my novice test. His call was W2 King Victor George, Norm, who lived nearby.
And so you got your novice license, and off you were on 40-meter CW?
Well, it was difficult. You know, I don't know how familiar you are with the housing in the borough of Queens. They're fairly small, two-story houses that are that share walls, and the roof area was quite limited. It was about 30 feet by maybe 25 feet. So a 40-meter dipole type antenna would be very difficult. It would have to bend. So what I did is I was able to lay a 20-meter dipole on the roof, and I used 72-ohm twin lead, which was available at the time. And it didn't work too well on 40 meters, as expected. But I didn't know too much better at the time. So I made several contacts on 40. It was kind of interesting because the 40-meter band was so busy, the novice band was so busy, and with an S38E receiver, it really required me to have sharp ears to pull out the signal. I didn't have any selectivity at all on that receiver.
Now, this might have been, post-war renaissance for amateur radio, and with a lot of kids getting into it then. Obviously, with 197 episodes, I think, in at this point, we've talked to a lot of hams that came in from the 50s. Were you active in a ham radio club in high school, and were there, lots of fellow hams your age?
Yes. I went to a high school in Brooklyn called Brooklyn Technical High School. And we actually had a commercial FM station on the roof, WNYE, and I think they're still there. And we had our ham shack up there also, and it worked out pretty well. It was very interesting.
Okay, so you say you have the S38E as a receiver. Your first rig, what was the first transmitter that you had?
It was a Heathkit DX40.
Yeah, your roof sounds like my current roof, the roof you had in Queens. It's I think that's about the size of my roof. So inverted V's are in.
Yeah, well, even inverted V's weren't an option. I did use verticals that work quite well, ground plane verticals like the high gain 14 AVQ. That was pretty effective. Even on 40 meters, it was a good antenna because we had a good location. My parents' house was located on a ridge, one of the highest points in the borough of Queens. So it had a good takeoff in many directions.
Now, were you very active as a novice in order to get to upgrade your code speed and to upgrade your license?
Yes, I was active, but my studies and schoolwork came first. And my dad saw to it that was the case. Generally, I did not operate at all during the week, and I would have some time on weekends to do operating.
Did ham radio play a part in the choices that you made for your education and career?
Definitely did. I don't know if I would have gone into electrical engineering if it hadn't been for ham radio, but I would say ham radio and my interest in electrical engineering went hand in hand. For example, in ham radio, I still had many questions about electronics, about communications theory, and I looked forward to taking courses in those areas to allow me to understand these areas better. So it went hand in hand. And once I understood it from a more academic level, I could go back to ham radio and apply it to my understanding of operating the station.
We should all know that I'm talking to Dr. Jack Mandelman. Where did you go to school and how did it proceed from there?
After high school, I went to the City College of New York. I got my bachelor's degree in electrical engineering, then my master's degree in electrical engineering, and I was encouraged to go on to get my doctorate, which I did. When I say electrical engineering, electrical engineering is a huge field. There are many aspects of electrical engineering. So for my doctorate, I focused much more on semiconductor devices and solid-state physics.
And did you also do your PhD at CCNY?
It was at CCNY, but the PhD degree is given by the City University of New York.
Okay, so what happened after that? I mean, you got your PhD. What was your thesis in?
It was microstrip distributed P-nu N diodes. A P-nu N diode is similar to a PIN diode, but what I studied was trying to take advantage of the distributed properties of the structures that I was investigating to see if we could get some interesting characteristics out of them at microwave frequencies. Now, at microwave frequencies where the wavelength is much shorter than at the short wave frequencies, of course, and still relatively long compared with the dimensions we're talking about for semiconductor devices, we get some very interesting properties. The semiconductor device itself, the wave propagating on a semiconductor device can propagate as a slow wave, which means that the physical wavelength is reduced drastically. And because the physical wavelength is reduced, we can take advantage of the so-called distributed properties of the device.
It seems to me that you're entering this area of semiconductors and solid-state physics at a time when I think we're racing to the moon and then racing into the computer age. Do you feel that you are kind of a pioneer in a lot of the microelectronics that are now used today?
Yes, I do.
What were those times like? It seems to me that we've had a number of guests on from the Bell Laboratories in the 60s and 70s, and people who were involved in the creation of the internet and computing and the RF industry as it evolved. It seems to me that this was a fascinating time to be an engineer.
Absolutely, but we didn't really grasp that until we look back years later to see how amazing those times were, how quickly things moved. For example, when I first started in the semiconductor industry, my first project that I was working on was a memory chip. It was actually a static RAM, an SRAM, that stored 1,000 bits. Now, towards the end of my career at IBM, I was working on a project to develop a 1 gigabit DRAM, dynamic random access memory. So that was 1 billion bits. You're talking about in a span of 30 years or so, the amount of information that can be stored on roughly the same size silicon increased by a factor of 1 million. Isn't that amazing?
I think it's absolutely amazing. But what did we do? Obviously, our process is over a 30-year period. may have been subject to Moore's law, right? So every few years we double in our capability. But what do you think is responsible for that? Do you think it's because so many people were working on it at the same time? Do you think the space industry, at least getting to the moon, accelerated this whole process and kind of put us into the stratosphere?
That's true. That was part of it. And it had a momentum that fed on itself. We realized that Moore's law worked very well at that time. The situation's a little bit different today. But scaling of the semiconductor devices proceeded on a pretty regular schedule, density doubling about every 18 months. That has slowed down quite a bit now. We realize that the structures of these devices can be scaled, and we can still get more performance and higher densities, more function in the same area on the chip, and that continued for quite some time. I would say for 20, 25 years before the curve started bending over a little bit.
Did the factories that produce this stuff, did they have to be retooled constantly in order to be able to keep up with innovation? Or the way this stuff is made now, I guess the question is yes, right? Or the answer is yes?
Yes, very good question. Because what happened was the pace of change in the industry was so great that it required different tools to introduce new processes for deposition, depositing materials, for etching materials, different etching processes, a new lithographic processing, and new processes for introducing impurities, so-called doping into the semiconductor device. So the tooling was constantly changing, and it was very expensive, and there was a lot of shakeout in the industry because smaller companies couldn't compete. That's why the larger companies succeeded so well. They had the money to invest. I would say in the middle to late 1990s time frame, it would cost about $5 billion to build a fab, a facility to fabricate chips.
So in other words, if you were a large analog devices or TI or something like that, then you were kind of leapfrogging your fabs in order to be able to continually to produce product while being ready to produce the next product. Absolutely.
And as a matter of fact, that's why you see so many fabless companies now. They just do the designs, they do the layouts and the circuit designs, and then they send it out to semiconductor foundries to have their chips made.
Now, where did ham radio fit into this as you're a professional for over 30 years in the microelectronics field?
Well, I found that many of my colleagues were interested in ham radio and had ham radio licenses. At IBM, when I was working in the Burlington, Vermont area, we had a very nice radio club there. And I was actually the trustee of the K1VT repeater on 2 meters.
In Burlington, Vermont.
It was actually in Essex Junction, Vermont, which is the greater Burlington area.
Well, I found online that there's actually a website that is a worldwide listing of amateur radio operators that worked for IBM.
Yes.
Did the company itself cater to hams and ham radio? Did they see that as that their hams were an asset to the company?
I think at one time that was true. Times were very good at IBM in the 70s and 80s. And then things became more challenging because of the pace of change of the industry and certain directions that the company had to follow in order to continue to be competitive. So when that happened, the funding for ham radio activities diminished, and it really wasn't encouraged to that point. I think back in the 70s and 80s, it was given a pretty high priority by the company, or at least the management at the Burlington site.
What's unusual in my thinking here is that I actually didn't realize that IBM was so involved in R&D. And when we think of IBM, as a company, we think of mainframe computers and stuff. But obviously, they must have been designing their own silicon to go into these computers. How large was their R&D process, around this? And did you stay with them throughout your career? Or did you go someplace else?
Well, when you ask the question, how large, do you mean in terms of the number of employees?
Yeah, when we think of IBM, I think of System 38 or the IBM 370 that I learned how to write Fortran on. So there's obviously a lot of silicon in those things. But
Yes.
It never occurred to me that perhaps that IBM wasn't buying that silicon from somebody else. They might have been actually building it themselves or designing it themselves. And you were there for a long time. You've got over 480 U.S. patents and 725 patents worldwide, from what I can read. It seems to me that for those of us like me who didn't know that IBM was in the R&D industry at this level, that seems quite unusual. I mean, that seems like that's not the usual perception of IBM.
Well, I'm surprised because it depends on who you're talking to. Some people do recognize the fact that IBM is heavily invested in R&D, and that was the case back then. The emphasis in the R&D does change over the years, depending on what technologies offer the most promise for the future. But back then, there was a huge R&D effort in silicon semiconductor technology, and it was mainly orchestrated from the research site at Yorktown Heights, the Watson Labs. But there was still quite a bit of R&D at Burlington and East Fishkill.
Let's take this quick time out to hear a word from our sponsor, ICOM America. May is D-Star month at ICOM America. This week we are featuring the D-Star ID51A Plus 2 dual-band D-Star and analog portable transceiver. The features packed in this tiny D-Star handheld can't be beat. These features include a large LCD display that shows your main and secondary channels and menus for easy programming of the radio without software. A built-in GPS allows you to find your position anywhere in the world, but to also find the nearest D-Star or analog repeater to your current location. The ID51A Plus 2 features dual-watch, dual-receive functionality to allow you to monitor your two favorite channels at the same time, regardless of frequency band and mode. You can even listen to broadcast AM and FM radio stations on the ID51A Plus 2, making it a versatile travel companion. The transceiver includes software and cables to allow you to interconnect your ID51A Plus 2 to your computer or any Android smartphone or tablet, giving you even more capability on a bigger screen. When paired with a smartphone or computer, the transceiver can become a D-Star access point when used with another D-Star portable like the ID31A Plus. The ID51A Plus 2 has a built-in SD card to allow you to back up your radio and even record audio of your conversations to other hams while using the radio. There are some great video demonstrations of this amazing radio on YouTube. I will put links under the ICOM banner on this week's show notes page. Visit ICOM America at www.icomamerica.com/amateur, or as this podcast is being published during the Dayton Hamvention, be sure to visit the ICOM booth in Building 2 before the show ends on Sunday. The ICOM ID51A Plus 2 D-Star handheld should be on your belt or in your go bag. It can be purchased from any ICOM distributor or retail location. Please be sure to say when you purchase this or any other fine ICOM transceiver that you heard it here on QSO Today. And now back to our QSO. And did IBM ever build their own fabs?
Oh, yes, definitely.
Really?
Definitely. We designed and fabricated the chips for our own products, and that went into the 360s, 370s, 390s, etc.
So as a young electrical engineer in the 80s, I wouldn't have gotten data books from IBM then because their silicon wasn't sold on the open market.
That's correct. It wasn't sold on the open market. Later on, in the mid to late 80s, IBM began building chips for customers. In other words, they had a foundry operation in addition to the satisfying the internal needs. They made chips for other customers that put into their own products. For quite some time, IBM processors went into Apple computers. I don't know if you're aware of that.
I was not. That doesn't that doesn't mean the rest of the world doesn't know it, but I was not aware that IBM was making processors. I think I would have thought Motorola was the one that put processors into Apple products.
Well, that was probably much
later, right?
Much earlier.
Huh, how about that? Well, that's very interesting. Well, what do you think is the most significant science that you did at IBM that might have the longest-term impact on the things we're doing today, perhaps?
It's hard to say. I would say the majority of the patents are incremental, but incremental patents can have a huge effect. It could have a snowballing effect because it sends things in the right direction, or in a certain direction anyhow. So it's very hard to say which ones are the most influential. I would say that all of them had some influence, some more valuable than others. But off the top of my head, I can't answer that question. The thing is, I was very lucky to be working in an area where everything came together for me. I would say it was a convergence of many factors, such as technical maturity, being able to see a much larger picture of the way things fit together, and being in the right place at the right time. Being successful as an inventor is due to several important factors. One is nature, nurture, and good fortune. So most of my inventing came when I was working on a project to develop an advanced memory chip. It started out as the 256 megabit DRAM, dynamic random access memory chip. The project started in 1992 and ended in year 2000. And we were cutting new ground all the time. Every day we discovered new problems. And I mentioned earlier that a good part of my work involved modeling semiconductor devices using something known as finite element modeling. And because of that, it gave us a crystal ball into what we can expect and what problems we can expect. I think the key to being successful in innovating is to understand what problems are going to arise before anyone else understands it. So we had a real head start on that. And by recognizing what we have to face in the future, we can concentrate on that and concentrate on solutions. And that's why it was such a fruitful time for inventing, those 10 years from 1992 to 2002.
Was IBM still designing and modeling DRAM in 2002? Was that were you at IBM?
Yes, I was. So at the end of that project in 2002, I decided it was a good time to retire from IBM and try something else. I wanted to teach in the field, not at a very high level, but an opportunity came up to move here to Western North Carolina and teach at a local community college. I taught electronics and math for 2 years. But after 2 years, I didn't find that too challenging, so I looked elsewhere, and IBM hired me back as a consultant for a few years, which led to more inventing. At the time, I reported to Rochester, Minnesota.
Yeah, again, the inventions were in this area of microelectronics.
That's correct, yes.
It's my understanding, we talked a little bit beforehand, that you're now taking the antennas down from the place that you're living in. In fact, you're moving into a maybe a more planned community, as it were. I guess that's what they call them in America, a planned community, which might make it difficult for you to have antennas. But when you had the antennas up, and it's my understanding that you like to experiment with antennas. What kind of antennas did you like to experiment with, and did you come up with any unusual designs that had some dramatic effects?
Yes, I think the most interesting one was an antenna known as a lazy H. It's nothing new. It's merely two stacked doublets, and that worked very well over a fairly wide frequency range. I found that since I couldn't rotate the antenna, since it was a wire antenna, I wanted to maximize the azimuth area covered and get gain from the antenna by squeezing the vertical radiation pattern down. And stacking two antennas does that without significantly affecting the azimuth pattern. It compresses the vertical pattern and gives you some gain because of that. That lazy H worked very well. Now, I improved that on that design somewhat by adding a third doublet that was phased with the two previous doublets in the lazy H in such a manner to compress the pattern further. So that was a little experimenting that I did after doing many simulations to fine-tune the design.
We mentioned off the mic that you actually like to model antennas with antenna software. Which modeling software do you use for antenna design?
Okay, I use the software called 4NEC2, the number 4, NEC, the number 2. And that's it's been around for at least 10 years. It's written by a fellow named Ari Vors, ARIEVOORS, and it's a magnificent program. It's freeware, has a bit of a learning curve, but once you get a handle on it, it's amazingly useful.
Did you write any white papers on your three stacked doublets?
No, I didn't.
Do you like to work DX? And do you have any stories of some fabulous DX you got from these antennas?
Not specifically from these antennas. I do like to work DX. I'm not a DX chaser in a big way. As I said, I'm a casual operator. I like to rag chew, and I like to snag DX if there's some interesting DX around, or I like to rag chew with DX stations. I've had some very interesting chats and rag chews with stations overseas, but when I lived in Vermont, I had the freedom to put up more effective antennas. I had towers and rotary antennas, and back then I was much more into DX because I had more effective antennas. And I remember handling traffic for Father Moran in Kathmandu, Nepal, and it was pretty exciting back then because he would call me on 20 meters when I was beaming over the North Pole, and I'd have some traffic to handle for him.
Well, that's pretty cool. And what is your favorite operating mode?
My favorite mode remains CW. I enjoy CW. I find it relaxing. It's kind of an exercise for the brain, I believe, because of the focusing that is necessary.
Well, I see that you're a member of CW Ops. Are you teaching CW as well as being a member?
Well, I encourage people to use CW. I will slow down to the speed that whomever I'm speaking with is comfortable with, and encourage them to persist. I think very few are born with a natural ability for CW, and usually it just takes a lot of work and a lot of persistence to come up in speed. You're going to hit plateaus. It's very typical to hit plateaus in CW where you don't think you can go any higher in speed, especially with copying. But it turns out that if you're persistent, frequently you can break through those barriers.
Right, like anything else, if you're persistent, you can actually break through. It's a 10,000 hours thing, right? If you've done it for 10,000 hours, you've probably mastered it.
Something magic happens. All of a sudden, things come together, and something magic happens, and you realize then you're taking off again.
Right, until you hit another plateau.
That's right.
That's pretty cool. Well, what's the current rig?
For HF rigs, I still have the K3 and the P3. I bought an SDR radio, an Apache Labs, an Anon 200 Delta, which is a dual receiver, two independent receivers on SDR, and I've enjoyed working with that rig. I also have an IC 7300, which I consider more of a go-to rig because it's so simple and easy to operate. So those are the three main rigs that I've been using on HF. And as I said in the prelude to this interview, I operate now HF from my car because I took down all my HF antennas in preparation for moving to a smaller QTH. And I wanted to get my house in shape so that we can put it on the market. So right now I'm using an HF setup, which consists of an ICOM IC 7100 with a Tar Heel screwdriver antenna. And it actually works better than I expected, especially considering how poor conditions have been lately on the HF bands.
Well, and you're operating CW. With the 7100, you're 100 watts in the car?
That's correct, yes.
So don't hang on the Tar Heel while you're transmitting.
No. One nice thing about operating mobile is that I can drive around and find a spot that may be more favorable to propagation. For example, being situated on a ridge overlooking just more or less open space in a certain direction that I'm interested in. And also I can drive around and find a spot that's very quiet as far as RFI is concerned. And that's becoming more difficult these days with the preponderance of equipment in homes that generate a lot of interference. There's a lot of RF pollution. So driving around, finding a nice clear spot, quiet spot makes a tremendous difference. It's just a pleasure to be able to listen without having a lot of RF noise. So mobile operation is not all that bad. Of course, you're not going to be as competitive as having a big fixed station, but it's something different by itself. And it's in certain ways it can be more relaxing. You can always go to a nice peaceful spot and park and operate, and that in itself is worth the experience.
Now, do you operate CW as you're driving?
No, I don't. I could, but I don't because I consider driving very serious. So I don't. I would park and then operate CW. Now, if I would operate phone, as I do on digital voice modes or even phone on HF, I would talk while I'm driving. It doesn't require the amount of concentration that I have to put in on CW.
And now this message from QRP Labs. QRP Labs has shipped thousands of QCX QRP transceivers kits to date. The odds of working another QCX user gets better every day. If you're looking for a satisfying kit experience where you end up with an amazing performing QRP transceiver for under $50, let me say that again, for under $50, then you owe it to yourself to go to QRP Labs. We have many home brewers who listen to the QSO Today podcast. For you, QRP Labs also has parts, filters, enclosures, and other handy devices to make your home brewing experience even better. You can use these parts to either enhance your QRP Labs kits or to beef up your own homebrew designs. Be sure to browse Hand's entire website. Use the link on this week's show notes page or the one in the sponsored section of the QSO Today website to get to QRP Labs to buy your QCX or any of the other fine QRP Labs kits or parts. QRP Labs is my go-to ham radio kit company. It should be yours too. I sent you an email and told you that you were on my prospect list. But the reason that you're here today is because I spoke to you on the Baynet DMR Talk group earlier in the week, which I thought was very cool, which also means that you're operating DMR. What do you think of DMR now that you're on there?
Well, it's fascinating. not just so much because of the talking, but because of the technology behind it, and trying to understand it. It's a different aspect of engineering and electrical engineering than I'm accustomed to. I have a lot to go to get up that learning curve. I'm pretty far down the learning curve now, and I still have a great amount to climb. And what I enjoy is learning new things and trying to understand things in a better way. I find that as I get older, it's more challenging to grasp these things. When I was younger, I found that it was much easier. I could more or less sit on a book and learn the material. But now it's quite a struggle. I don't know if it's just so much me or the complexity of the technology or just the way the technology seems today. It's very foreign to what I'm accustomed to. And it is ham radio. I say many people criticize digital voice. Well, it's not ham radio, but I disagree with that because the people I speak with on digital voice have a common interest, and that is in communications. And I think ham radio is about communications. It's just the technology is changing. Over the course of my ham radio career, I remember several times when there were paradigm shifts, and there was so much opposition and so much bickering on the air about which mode is better than which mode, and if you're not loyal to a certain mode, it's considered heresy. And a similar thing is happening with digital voice, but I think it opens up new areas, especially if one cannot put up an elaborate fixed station. So the interest came along at the right time in my life. Downsizing to a smaller QTH, I know I'm going to have some big antenna challenges, and I consider digital voice modes something that's going to fill that niche.
And how are you operating the digital voice or DMR right now? What are you using?
You see, locally, we don't have any Brandmeister repeaters. Brandmeister is very popular on DMR, and I like the Brandmeister network because it's so active. We have one DMR repeater locally that is linked to one of the Brandmeister talk groups. So for the most part, I'm using hotspots. I have a Shark RF open spot, and I also have a BlueStack. The BlueStack is a DV Mega on top of a BlueStack board. The software I use with that is called Blue DV. And I also have what is called a Thumb DV. It's a little dongle that has a chip in it known as an MB3000, AMBE3000, which is a vocoder chip, converting between digital and analog in both directions. And that plugs into a computer. It could be a regular Windows computer or a computer running Linux, or it could be a Raspberry Pi. And I find that very versatile because with the Thumb DV, the dongle, I can just plug it in and work either D-Star or DMR. I haven't tried it on Fusion yet, but it's nice to be able to work both D-Star and DMR. I don't have a D-Star radio in my shack, so I wanted to get the Thumb DV dongle to get more familiar with D-Star, and then perhaps get a D-Star HT. I don't know. But in the car, the IC7100 does D-Star, and I can operate through a D-Star repeater if need be. But in the car, I even use a hotspot. I use the BlueStack in the car because I don't have to worry about hogging a repeater. On D-Star, when you link to a reflector, that is the reflector that is active on the repeater at the time, and you may be infringing on somebody else's interests who want to use a different reflector or use the repeater for a different purpose.
Yeah, I'm finding with DMR, I just put a DMR radio in my car, and I'm finding it interesting from the standpoint that we have a talk group that's on one side. I mean, these repeaters, these DMR repeaters have two talk channels or simultaneous channels. And then all the part-time stuff is on the other talk channel. So if I talk to you on Baynet, then I think I have to keep chunking it at least every 15 minutes to make sure I still have it or that I'm still listening to it. And part of the problem is if you're sharing that repeater with other people, you don't really know whether it disappeared on you and went someplace else. So there's a learning curve, it seems to me. But if anybody listening to the Ham Radio Workbench podcast, I think George and Jeremy spent 4 hours on DMR, so that's a good place to go and get your DMR primer. But you seem excited about DMR. You know, I hear the excitement in your voice from just the prospect of playing with all these open spots and the DV Megas and just trying to make sense of the whole thing.
Well, there's much to learn in the whole area of digital voice, and you can go as deep or stay as shallow as you want, and that part I find exciting. So I have certain projects that I'm going to try. I would like to set up a server to serve the data I get from my MB3000, and then access that via my smartphone wherever I am in the world.
Oh, that's pretty cool too. And that's ham radio. So, or at least this is as you said, at the very beginning, you were talking about how electrical engineering was this huge tent. And I think, ham radio has become this huge tent as well. So there are people who are, who are working in the trenches on, say, transmitter and receiver design. And then there are people on the other end that are working in the microwave, and then there's some of us in the middle that are kind of playing with all of this new digital technology that we can connect to Raspberry Pis. I think it's all quite remarkable.
Yes, it is, and the field has expanded in recent years. It's expanding rapidly, so there's enough room for any interest in ham radio.
What kind of impact has amateur radio had on your family life?
Sometimes it interferes, but I would say not to the extent that I've seen with some of the other hams I know. Some of the very serious contesters do have big problems with their family because contesting often requires dedication to a contest over a weekend. And I don't get into that situation. I'm not a contester. But I would say it requires some understanding on both parts. My wife has been very understanding. When we were looking for this house that I'm living in right now, 16 years ago, one of my requirements was that it have tall trees around the house, which I call antenna trees. And my XYL put up with that for 16 years. So now that she wants to move to a place that's that requires less maintenance, I'm trying to accommodate. So I would say there's a lot of give and take. You have to have a lot of give and take. It's not one-sided. So if you have that understanding, I think things work out okay with family matters.
Can we go to the trees for a second? Because I'm kind of fascinated by the whole tree idea. I've never lived any place that had tall trees. Do you climb those trees to put those antennas up at 100 feet, or do you hire a rigger, or do you use a potato launcher? How do you get the wires up there?
Well, when I first moved here 16 years ago, the first antenna I put up, I hired an arborist who had a huge slingshot. I'd estimate the span on the slingshot was, I don't know, maybe 3-4 feet, and he launched a bag of weights over a limb that I was interested in, and that got my first antenna up. But after that, I decided to build a pneumatic tennis ball launcher. I used plans that were online, and I put together the components, mostly from PVC and commonly available sprinkler valves, and put that together and used that over the years to get lines up at the 100-foot level. I found that pneumatic tennis ball launcher was quite precise in hitting the limbs of interest, as long as the wind wasn't a factor. So you wait until you get a fairly calm day and you can get a fishing line. I used a 50-pound test line. It was not monofilament. I'm trying to think of the name of the line, but it was 50-pound test, and that allowed me to pull up heavier lines. First, I pulled up Mason cord, and then I pulled up Dacron rope. Dacron rope was made specifically for outdoor uses such as antenna work. And that lasted amazingly well because when I took down some of the older antennas that were up around 16 years, the Dacron rope was still good. It hadn't deteriorated. So having that launcher was a big plus. I have since given it to the local radio club here in the area.
Okay, now when you say pneumatic, that means that it was air driven. You weren't igniting gas behind the ball.
That's correct. I would pressurize a chamber in the device with a regular tire pump. You could use a manual pump. I used an electric pump, battery operated. It took a very short time to get it up to pressure. Typically, I'd use 60 pounds per square inch. And that was sufficient to hit the limbs at the height that I wanted. If you go much higher than that, you can easily overshoot. And also, I didn't want to use such a high pressure that it could become a hazard. I would say if there was a failure in the PVC, it could fragment and cause a lot of harm.
So I'll put notes to a pneumatic tennis ball launcher with using PVC pipe in the show notes. What excites you the most about what's happening in ham radio now?
I would say digital voice modes and also a satellite operation, which I haven't gotten into yet.
But it sounds like if you can't have antennas, going out into the front yard with a dual-band Yagi and pointing at the satellites might seem like a good idea.
Yes, I would like to try that. And if not in the front yard, I could go to some nice spot. I can get in the car and drive to some nice spot and do it from there. The other thing that interests me in ham radio now is the challenge of using antennas in the attic. I will have an attic, although not very high above ground. It will go from about 12 feet to about 18 feet above ground. But there are ideas that I'm going to try. Specifically, I would like to experiment with small transmitting loops, also known as magnetic loop antennas, which can be very effective. Now, the big unknown in moving to any new place, especially where the population density is high, is how much noise and interference I'm going to receive from other devices in the neighborhood and how much interference I'm going to cause. And that's a big unknown. You know, I may have to adjust my power output accordingly to prevent interfering to other devices. Now, if I hear a lot of noise, a lot of RF noise, I'll have to experiment with receiving antennas. And small receiving antennas I can probably put up outside in unobtrusive places. And I can orient them in such a manner to reduce the noise impact.
Oh, you could always remote your SDR Apache labs.
Yes, remote operation's a possibility. It interests me, but it's not as exciting. I think it's good if you just want to get on and just talk. And I have dabbled in that. There's an application called RC4, might be remote ham radio. There are two remote organizations with similar names. This one is totally free, and there are quite a few remote stations available that you can either just listen on or you can listen and transmit.
Yeah, I think that's remote hams, and I'll put that in the show notes page as well. No, I'm thinking of get a little piece of property. That's where you build the ham station. That's how I'm thinking. I'm thinking little place to put the ham station, a place to go to get away from home and work on the antennas and putter around the shack there. That's what I was thinking in terms of a remote ham station.
Yeah, that's a possibility. And as you talk about that, I was thinking there may be some neighboring property. You know, the development that I'm going to be moving into used to be an apple orchard. And the developer cuts down all the trees, so there are no trees except for a few twigs growing out of the ground. But around the area, there's a farmland that's pretty rural, and maybe one of the neighbors could allow me to put something up there. And I was thinking, even if I have a visual path to that location, I wouldn't have to use an internet connection. I could just use a UHF or microwave link to communicate with the remote station.
Yeah, now we're thinking on the same channel. That's actually what I'm thinking about too. What advice would you give to new or returning hams?
What advice? Well, prepare for a shock. It's a whole new world, and don't be overwhelmed by it. I think use what you know already. For example, if you're an old-time HF radioer, I would say listen on the HF bands. Do more listening than talking now, because by listening you're going to be picking up what's current, and you may hear certain things that really interest you. And when you hear those things that interest you, then dig into it a little bit more. Get online and try to look up answers to your questions. I think we have tremendous tools now with the information available online, and with all the forums on there. Don't be afraid to ask questions, and just be prepared to be shocked by it.
You know, besides the QSO Today podcast, Jack, which ham radio podcast do you like?
Well, I think my favorite one is Ham Radio Workbench. I think that's the favorite one.
Well, that's my favorite too. What can I tell you? I love listening to that podcast. So anyway, podcasting is also a great place to, or ham radio podcasts are also a great place to learn more about ham radio.
Oh, definitely. And YouTube. You know, I go to YouTube.
Absolutely.
Yeah, I look up things on YouTube. Now, all the information you see on YouTube is not correct all the time, but some of it is extremely valuable. And I've learned a great deal about digital voice just by looking at YouTube. And many of the questions are not answered. So
right.
The ones that are not answered, I have to dig into some of the forums or even post some questions on the forums.
Yeah, but we have an amazing ability now, don't we, to look at information. And I guess most people don't realize also that you can run the YouTubes at double speed. So, you know, you can speed them up and get through it much faster if you're trying to call out information on a subject to see whether or not the guy you're listening to actually knows something or he has a point that he makes much later. So I like running them at double speed.
I haven't tried that yet, but what I do is sometimes I'll click ahead and skip the sections that I'm familiar with, you know, and get to the area that I'm most interested in.
Well, Jack, I appreciate your joining me on the QSO Today podcast. I'm excited to hear what happens to you at the new place in terms of whether your antennas are successful. I hope to hear you on DMR, which I'm pretty sure I will. And with that, I want to wish you 73 and thank you for coming on the QSO Today podcast.
Well, thank you very much, Eric. It's been a pleasure.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Jack. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in K1VT in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links on the show notes pages or by using QSO Today in the coupon box at checkout. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I'm grateful for any way that you can show appreciation and support. It makes a real big difference for me. QSO Today is available on iHeartRadio now and in the iTunes Store and a host of podcast services and applications. Stitcher is still my favorite, with over 4,000 hours of podcast listening. Until next time, this is Eric for Z1UG, 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.